Here we have a formula for the nth term of a sequence, and we're being asked to find the first four terms. So this n is just representing the term of the sequence. So if we're asked to find the first term, that would indicate that we want to plug a 1 in for n. So we get a1. We put a 1 in place of the n there, so we also put a 1 in place of the n's on the other side of the equation. So a1, which is the first term, would be negative 1 to the first power over 2 to the first power plus 1. Negative 1 to the first power would be negative 1. 2 to the first power is 2. And 2 plus 1 would be 3. So we get negative 1/3 as the first term of the sequence. The second term would be represented by a2. Since we put a 2 in place of n here as a subscript, again we also put 2 in place of n on the other side. So we get negative 1 squared over 2 squared plus 1. Negative 1 squared means negative 1 times negative 1. That's positive 1. 2 squared is 4 plus 1, and 4 plus 1 would be 5. So we get 1/5. Then a3, that's the third term. So plug in a 3 for n, so it's negative 1 to the third over 2 to the third plus 1. Negative 1 to the third would be negative 1 times negative 1. That's positive 1. Times negative 1 again, so that's negative 1 over, and then 2 to the third is 8 plus 1, and 8 plus 1 is 9, so we get negative 1/9. And then finally a4, that's the fourth term. We plug a 4 in for n, so we get negative 1 to the fourth over 2 to the fourth plus 1. So negative 1 to the fourth, we could take our negative 1 cubed, which came out to negative 1, times negative 1 again, and that would give us positive 1 over 2 to the fourth is 16. 16 plus 1 is 17, so we get 1 over 17. So our first four terms of the sequence are negative 1/3, 1/5, negative 1/9, and 1/17. This is called an alternating sequence because the terms alternate from negative to positive to negative to positive, and that pattern would continue if we kept evaluating terms.